Okay, I'll do 18 and 19 together. Now we're in a new chapter. We are in, let's go back. We're in chapter 9, testing the difference between two means, two proportions, and two variances. We're only going to be talking about two means. So these formulas here, and then these formulas, these first two formulas, the first three formulas here. Different formulas if we're talking about independent samples. Z-test for two means independent samples. T-test for two means independent samples. And then we also have a T-test and a Z-test. No, just a T-test for dependent samples here as well. All right, so formulas look a little crazy. Don't feel any kind of way about them. Don't get nervous because of those formulas or anything. They'll be fine. Okay, so a test was made of null hypothesis. Mean 1 equals mean 2. Remember, always the statement of equality. Alternative hypothesis is that the first mean is less than the second mean. Left tail test all day, every day. We're given the sample means, x1 bar equals 16, x2 bar equals 7, and the sample standard deviations, S1 is 5, S2 is 6, sample sizes, N1 is 17, N2 is 18. We're given all these information about each of our samples. We've got two samples here. Now, population standard deviations are not known. Right? We know the sample standard deviation, so this is a t-test with degrees of freedom. So if we look at the degrees of freedom for N1, N1 minus 1, the degrees of freedom there is 17 minus 1 is 16. The degrees of freedom for N2, 18 minus 1 is 17. Now, which degrees of freedom do I use for my test statistic? Because I'm only going to have one to test statistic here. Go back to my formula sheet. It tells us t-test for comparing two means independent samples, variance is not equal. Degrees of freedom is the smaller of N1 minus 1 or N2 minus 1. Whichever degrees of freedom are smaller, that's the one we use. So the degrees of freedom for N1 are smaller. So these are my degrees of freedom. My degrees of freedom is 16. It's number 18. Number 19. Number 19, a test was made of null hypothesis. Mean 1, mean 2 are equal to each other. Statement of equality. Alternative hypothesis is that mean 1 is less than mean 2. The sample means, x1 bar is 14, x2 bar is 6. Sample standard deviations, 6 and 7 is going to be a t-test. N1 is 16, N2 is 19. The degrees of freedom here, just like the previous example, are going to be the smaller, 16 minus 1. So that's going to be my degrees of freedom. Compute the value of the test statistic. So if I go to my formula sheet, t-test for comparing two means, independent samples, variance is not equal. Here's our formula. Okay, so I'm going to try to write this out. T equals x1 bar minus x2 bar, right? Minus mu1 minus mu2. Population means subtracted from each other. And these sample means subtracted from each other. Over, whoops, what did I just do there? Over the square root, S1 squared over N1 plus S2 squared over N2. Let's check and make sure that looks good. Yeah, it looks right. Okay, so the test statistic we're calculating. So x1 bar is 14 minus 6. Minus, the null hypothesis, we're assuming that the means are equal to each other, so m1 minus m2 has to be 0 if those means are equal, right? Over the square root of s1 squared, that's 36, over n1, plus s2 squared, that's 49, over n2, which is 19. Okay, so this is going to be 14 minus 6 is 8 over. Let's put all this in the calculator and see what we get. So I've got the square root. Oops, turn this on. Second square root. Whoops. I'll clear that. Second square root of 36 divided by 16 in parentheses. Still in the square root. Plus, in parentheses, 49 divided by 19. So see, this first parentheses here means everything's in the square root. 36 over 16 is in its own parentheses. 49 over 19 is in its own parentheses. 2.1975. 4 decimal places, right? 2.1975. 2.1975. So let's divide this. 8 divided by 2.9715. 2.692. So the t statistic is 2.69. I think I typed that in incorrectly. I made a little mistake there, didn't I? And nobody told me that I did something wrong there. That's not nice. What I meant to type was 8 divided by 2.1975. And I should have got 3.64. Sorry. 3.64. Now, you could have done this primarily with the calculator. The test statistic is 3.64. How could you have done that? I'll show you. So I'm going to stat, over to tests, and this is a 2-sample t-test, right? Sample standard deviations. 2-sample t-test. Now, if I had data points to enter, I would go to stat, edit, enter them in here, L1, L2, and go about that. But since I don't have any values, just go to stat, test, 2-sample t-test. If I had input data, I would have told the calculator where's the data, what's the frequencies, etc. But I just have statistics here, so I'm going to enter them. X1 bar is 14. Sample standard deviation 1 is 6. N1 is 16. X bar 2 is 6. Sample standard deviation 2 is 7. N2 is 19. Less than, not pool, don't worry about that, calculate. There's my t, 3.64. It gives you your p-value even for this, the degrees of freedom. That's another degree of freedom, not concerning us. But the important value here is that t-value. Excuse me. So you can get it with the calculator too.